In this episode, we're going to connect the idea of logging as a security control to the real goal most defenders care about: detecting suspicious activity early enough to reduce harm. Beginners often imagine detection as finding a single obvious clue, like a clearly malicious file name or a dramatic alert that announces an attack in progress. In reality, detection is usually the art of noticing patterns that look wrong for your environment, then validating those patterns with evidence. Logs are the raw material for that work, but raw logs alone do not create detection. Detection comes from knowing which events tend to be high signal, meaning they are strongly associated with attacker behavior, and from establishing baselines so you can tell what is normal from what is unusual. It also comes from having a workflow, because even a good alert is useless if the team does not know how to investigate it quickly and consistently. By the end of this, you should understand what high-signal events look like in general terms, why baselines matter, and how an investigation typically moves from an initial clue to a confident conclusion. High-signal events are log events that, when they occur, deserve attention because they often represent meaningful access, meaningful change, or meaningful failure of a control. They are not always proof of malicious activity, but they are valuable because they narrow the search space. For beginners, a simple way to think about high signal is to ask whether the event represents a doorway being opened, a lock being changed, or a boundary being crossed. Doorway events include authentication successes, especially into privileged accounts or sensitive systems, and also unusual patterns like many failures followed by a success. Lock change events include changes to accounts, passwords, permissions, or security settings, because attackers frequently try to expand access or reduce defenses. Boundary crossing events include a user or system reaching a network segment or resource that it does not normally reach, because attacker movement often involves crossing boundaries to reach higher-value targets. High signal can also include evidence of persistence, like the creation of new scheduled tasks or new startup entries, because persistence indicates an intention to stay. The key is that high-signal events represent actions that change the security state, not just routine noise. When you focus on high-signal events first, you make investigations faster and reduce the chance that important activity is buried under harmless chatter. Identity-related logs often produce the most useful high-signal events because identity is the key mechanism for access. High-signal identity events include privileged logins, logins from unusual locations or devices, repeated authentication failures, and sudden changes in authentication behavior for a specific account. They also include administrative actions like creating accounts, changing roles, disabling multi-factor authentication settings, or adding new credentials. For beginners, the important idea is that attackers either steal credentials or try to create their own path in, and both behaviors leave traces in identity logs when logging is set up well. Another reason identity logs matter is that they help you connect actions across systems, because the same account might appear in multiple logs. If you see a privileged login followed shortly by access to sensitive data, that sequence can raise confidence that the behavior deserves investigation. Identity logs also support containment, because if an incident is suspected, disabling an account or restricting access is often a quick way to reduce risk. High-signal identity detection is not just about one event, but about sequences, such as first-time administrative actions or privilege changes that occur right before unusual access patterns. System behavior logs also provide high-signal events, especially when they reflect changes to the system's security posture or unusual execution behavior. High-signal host events include the start of unusual processes, changes to security configurations, disabling of security controls, and installation of new software in unexpected contexts. They also include access to sensitive parts of the system, such as changes to authentication components or unusual interactions with system management tools. For beginners, it helps to remember that attackers need tools and footholds to operate, and those often show up as process execution and configuration changes. A single process event is not always suspicious, but patterns like a burst of new processes after a suspicious login can be a strong signal. Another high-signal category is persistence-related events, because attackers often want to survive reboots and maintain access. If you see new scheduled tasks, new services, or changes to startup behavior that do not align with normal maintenance, that is worth attention. System logs are particularly valuable when they can be linked to the identity that initiated the action, because that ties behavior to accountability. Network logs can produce high-signal events when they show unexpected connections, unexpected destinations, or behavior that looks like scanning or data transfer. High-signal network indicators include connections to unusual external destinations, repeated connection attempts to many internal systems, and unexpected traffic between systems that normally do not communicate. They also include unusual volume patterns, such as sudden spikes in outbound data from a system that typically has low outbound traffic. For beginners, the key idea is that attackers need to communicate, either to move inside the environment or to reach out to external infrastructure, and those communications often leave traces in network telemetry. Network logs are also useful because they can reveal behavior even when you do not have perfect visibility on the endpoint, such as when endpoint logs are missing or incomplete. Another important point is that network logs can help you spot boundary issues, like a sensitive network segment being accessed from a place that should not be able to reach it. When network signals align with identity and host signals, your confidence increases and your investigation can move faster because the story is supported from multiple angles. Baselines are what let you distinguish strange from normal, because without a baseline, everything looks suspicious and nothing looks suspicious at the same time. A baseline is a picture of typical behavior over time, such as normal login patterns for a user, normal network connections for a server, normal process activity for a workstation, and normal access patterns for an application. Baselines can be formal, such as calculated profiles, or informal, such as documented expectations that responders learn through experience. For beginners, the key is that normal behavior is not the same everywhere. A developer workstation might legitimately run tools and access systems that would be suspicious from a receptionist's laptop. A server that hosts public services will have different traffic patterns than a database server that should be isolated. Baselines also change over time, such as during business growth, system migrations, or seasonal activity, so baselines must be updated and interpreted carefully. The purpose of baseline thinking is not to declare that unusual equals malicious, but to use unusualness as a prioritization signal. When an event breaks a baseline, it becomes worth asking why, and the answer may be benign or malicious, but you now have a reason to investigate. A strong detection approach uses baselines to reduce false positives and to create more precise alerting. For example, instead of alerting on any administrative login, you might alert on administrative logins that occur at unusual times or from unusual devices. Instead of alerting on any network connection to an external destination, you might alert on connections to destinations that are new for that system or that occur in unusual volumes. Instead of alerting on any process execution, you might alert on execution patterns that do not match the system's typical role. For beginners, the important idea is that detection quality improves when you add context, and baseline is a major source of context. Baseline thinking also helps investigations because it gives you quick questions to ask, such as whether the user normally accesses this system or whether this server normally makes outbound connections at all. This makes your analysis more grounded and less driven by fear or assumptions. Baselines also help you measure improvement over time, because as you tune controls and reduce exposure, the baseline can become cleaner and more stable. When baselines are used well, detection becomes both more sensitive to real threats and less distracting with noise. Investigation workflows are the practical steps analysts take when they receive a signal, and understanding these workflows helps you see how detection actually turns into response. A typical workflow begins with triage, where the analyst decides whether the signal is likely benign, likely suspicious, or unclear but worth deeper analysis. Triage includes checking basic context, like the asset involved, the user role, and whether there were planned changes that might explain the behavior. The next step is scoping, where the analyst asks how big the issue might be, such as whether activity is limited to one account or one system, or whether it appears across multiple systems. Then comes evidence gathering, where the analyst pulls related logs around the time window, looks for sequences, and tries to reconstruct what happened. After that comes validation, where the analyst decides whether the evidence supports a security incident, a misconfiguration, or normal behavior. Finally, The workflow leads to escalation or closure, where a suspicious case is handed to incident handling with evidence, or a benign case is documented and closed, often with notes about tuning to reduce repeat alerts. For beginners, it is important to see that investigation is a structured practice, not a random search, and it relies heavily on good logging, good context, and disciplined documentation. An investigation also benefits from thinking in terms of questions rather than assumptions, because questions guide you toward evidence. A strong first question is what changed, because incidents often involve changes to accounts, systems, or configurations. Another strong question is what access occurred, because unauthorized access is a common root of harm. Another is what new behavior appeared, such as new destinations, new processes, or new administrative actions. Another is what the timeline looks like, because the order of events can reveal causality, like a suspicious login preceding a burst of network connections. Another is what did not happen, such as missing expected logs, because gaps can indicate logging failures or deliberate tampering. For beginners, this questioning habit keeps you from jumping to conclusions based on one clue. It also helps you communicate your reasoning clearly to others, because you can describe what you checked, what you found, and what that implies. Good investigation communication is evidence first, which aligns with earlier topics about incident handling and evidence preservation. Over time, this approach builds trust in your analysis because it is transparent and repeatable. When you bring all of this together, detecting with logs becomes a disciplined blend of selecting high-signal events, using baselines to add context, and following a consistent workflow to validate what the signals mean. High-signal events help you focus on actions that change security state. Baselines help you distinguish normal from unusual, and workflows help you turn signals into decisions. For beginners, the biggest takeaway is that detection is not about finding perfect certainty in one log line. It is about building confidence through multiple pieces of evidence that align, and then taking the right next step based on that confidence. If you collect and protect the right logs, you give yourself the raw material for detection. If you tune detection around high-signal behavior and baseline-aware context, you reduce noise and increase focus. And if you investigate with a clear workflow, you avoid getting lost in data and you produce outcomes that teams can act on. This is how logging becomes real defensive power, because it turns the environment from a black box into a visible system where suspicious behavior can be seen, tested, and addressed before it becomes a crisis.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.